In this video, we're going to talk about integration by parts. Integration by parts is the integration analog of the product rule. It helps us integrate when the integrand is a product of two different types of functions. For example, we might want to integrate x e to the x dx, or the integral of x sine x, or the integral of x natural log x. Or we might want to integrate e to the x sine x. In each case, the integrand looks like a product. But another type of integral for which integration by parts is really useful is when the integrand is just one chunky mess whose derivative is simpler than itself. For example, we might be interested in integrating just natural log x, or integrating arctan x, or the integral of arc sine x. In fact, it's useful if we wanted to integrate x arctan x. So let me tell you what it is and how we get it. The product rule tells us that the derivative of f times g is f of x times the derivative of g of x plus g of x times the derivative of f of x. So now I'm going to do some renaming. I'm going to let u equal f of x and v equal g of x. Okay, then du is f prime of x dx, and dv is g prime of x dx. So now I'm going to rewrite what I had before in terms of u and v. So the derivative of u times v by the product rule is u times the derivative of v plus v times the derivative of u. And now I'm going to integrate both sides. So let's integrate. So the integral of u dv plus the integral of v du. Now, on the left-hand side, the integral of the derivative of u times v is just u times v. So uv is the integral of u dv plus the integral of v du. And now I'm just going to solve for the integral of u dv. So I solve for that and get the integral of u dv equals u times v minus the integral v du. And this is called integration by parts. Okay. So the next thing we want to do is see how we use this. So let's do an example. So let's think about the integral x e to the x dx. Do we know an antiderivative off the top of our heads? No. So can we use substitution? Well, not really. If we let u be e to the x, its derivative is not sitting in the integral. So it's not a straightforward integral, and it's not going to be something we can use substitution. So we're going to try and completely transform this integral by using integration by parts. When you use integration by parts, you're going to choose something to call u and something to call dv in the original integral. And once you figure out what u equals and dv equals, you're going to figure out what du equals and what v equals. And you're hoping that v du is going to be easier to integrate. So u, hopefully, is something that's going to get a little bit easier when we differentiate. And dv is something we're going to have to be able to integrate. Okay, so let's suppose we say that u is equal to x. Then du is just dx. And if dv is e to the x dx, then v is simply the integral of e to the x dx. So it's e to the x. All right, so we're doing this labeling system where we've called this u and this dv. And integration by parts says that this should be equal to u times v, that's x times e to the x, minus the integral of v, that's e to the x, dx. Okay, so we started with an intractable integral, but look what we've come up with. We have e to the x times e to the x minus the integral of e to the x, and we know what that is. That's just e to the x plus a constant. Okay, let's look at something that I just swept under the rug. I said, if dv is e to the x dx, v equals e to the x. Well, that's one antiderivative, but should I have put e to the x plus a constant? If so, going back here, we would have said that the integral x e to the x dx is equal to x times e to the x plus c minus the integral of e to the x plus c dx. And let's see what happens. So we get x e to the x plus cx minus the integral of e to the x, which is e to the x, minus the integral of c. So we've got x e to the x plus cx minus e to the x minus cx plus another constant. And these two terms cancel out. So do you see that? We're back exactly where we were before. So you don't need to write the most general antiderivative up here. You just need to write some antiderivative.